welcome back to my channel, and in this video we are going to learn about space complexity. So let's see what it is. Before that, we always see that it is space complexity is nothing but it's the auxiliary space itself. But it's not the thing. Let's see what is auxiliary space first. Auxiliary space is the extra space or temporary space used by an algorithm. Okay, so it's just the extra space used by an algorithm. But what is space complexity? It is nothing but it is the total space taken by the algorithm with respect to the input size. Suppose there is an array of size n, then the space complexity would be of order of n. The reason being, see, when you take an array like this, and it is of how much size? N size. So it will be keep on going up to n minus 1. So here it is actually taking n spaces. So that's the reason here time complexity becomes order of n. When you talk about some constants like int k or int n and suppose you are having some for loop I is equal to 0 and so on. So for this all single variables, the time complexity would be order of, the space complexity would be order of 1 because they are taking just unit space. See, I value would be keep on getting updated based on the given conditions. Suppose it is I++, then it would get added by 1 each time. So the value of I is just getting changed, but it is not taking that many spaces. So that's the reason it would be order of 1. So now space complexity includes both auxiliary space and also space by input. So it would take the single variables as well as this array one. So now the total time complexity including array part and this single integer parts, it would be 1 plus n. So therefore total space complexity would be order of n. So this is how you calculate. So that's the reason it says both auxiliary space as well as space used by input. So now let's see different types of space complexities, and based on the given codes we'll find out its space complexities. The first type is order of 1. It is nothing but a constant space. Why is it represented as constant? Because whenever you are having any number like it might be order of k or order of 2 and order of 3. So these are all the constant values. So that's the reason together they are represented by order of 1. So let's see for this particular problem how we are going to get order of 1 as its space complexity. So first you write all the variables which are included in it. So n takes 1 unit of time, and sum also takes 1 unit of time. The reason being, see, when you go inside sum, its value is just getting updated. Like first if sum is equal to 0, then another time it would get 0 plus some element over here. Suppose this is equal to 5. So then this would be 0 plus 5. So the sum value is getting updated each time, but it is taking just 1 unit space. That's the reason it is also having 1 unit time. And when you come to the variable I, it is also taking 1 unit of time. So total how many units is it taking? And when you come to this, then this would be 3 unit time. Okay. You don't have to calculate an array part until and unless it is declared separately in the sub block of the code. Okay, so we need to just take the variables. We need to identify the variables and see how much time is it taking. Okay, so that's the reason 3 units. So its space complexity would become order of 3, that is equal to order of 1, because any constant would be represented in the form of order of 1. Now coming to the next example, it is order of n for linear space. Now let's see the linear space. Linear space is nothing but, see, here when you look at this, it has been declared of size n. So how many units does it take? B is nothing but, it is an array. So how does it look? Like this, and with how much size? Up to n. So that's the reason B takes n units of time. And n is another variable. So how many units does it take? Just 1 unit. And I would take 1 unit of time. Here A is just being used, so it would not be considered. Only the declarations like this would be considered extra, and the rest of the part are going to be taken as 1 unit time. So the total time would be now n plus 2. So the space complexity would be order of n. So this is how you find for this. Now coming to the next one, it is order of n square, nothing but a quadratic space. Okay, if suppose in your block of code you are having a line like this, wherein you are having two sizes, that is n into n. So this matrix would occupy a size of n square. Let there be any variables other than this I, j, all of them would obviously occupy just 1 unit of time. But when it comes to matrix, the size is n square. So it occupies n square unit of time. So the total time would be now n square plus 1. Therefore, space complexity would be order of n square. Now coming to the next form, that is order of log n. It's a logarithmic space. So this is very important actually. You need to understand its logic. When you come to binary search, what you do, suppose this is an array. Then you split the array into two parts by using mid formula. Mid is nothing but L plus R by 2. So using this, you split the array each time by n by 2. Okay. Next time when you search it in the first array, then you again take a different mid value. So this time it would again become half of n by 2. So first it was n, next it becomes n by 2, next it would become n by 4. That is nothing but n upon 2 square. Like that it would go up to 1, right, till it goes up to 1. We don't know when it would become 1. So let's take it as n upon 2 power k. So we need to equate this n upon 2 power k to 1, because we don't know exactly at which place it would be 1. So for that, 2 power k is equal to n, taking logarithm on both sides, it would be logarithm of n base 2 is equal to k. Okay. So now we have found the space per cell. Okay. The total space for the problems like this is calculated by number of calls into space per cell. Okay. So now when you look at this problem again, now if you look at the variables now, they are nothing but mid, L, R, and you also have x over here. So all of them, x, l, r, mid. So all of them take how much time? 1 unit of time. Okay. And how many times the function would be called as log n times. So this is nothing but the number of calls. Number of calls for space taken in an algorithm. So now the total space would be obviously, total space is nothing but order of 1 plus order of log n. Log n for number of times it has called, sorry, it's multiplication. Number of times the function has been called, and order of 1 is nothing but for all the integer values, like all the constant values. So that's the reason it would be log n. Therefore, space complexity is order of log n. So this is how you get order of log n for binary search. See, in any searching algorithms, you first have to understand the logic behind it. See, for binary search, we again and again split the array. Suppose we have split it into two parts. Now this is an array. This is the n by 2 array. So now we again split this part because we find new mid value for each iteration. So that's the reason each time it would get half. So this is one logic to remember before solving the space complexity. So that's the reason we find out number of calls and then space per cell. That's how you find the total space. Coming to the next question, it is combined space. See, whenever you get something like this inside any loop, this statement, it is having two variables. Okay, so this is nothing but it is taking n plus m space. In an array, suppose C is an array and you are having n is equal to m, then it is 2m. Then this C would have taken 2m space in an array. But now since both the variables are different, so this would take order of n plus m. You know, when do you use this? When you are having an array of size n and b array of size m, and you want to create a merged array of these both, then at that time you use array of n plus m. So in this you can store n plus m elements. So that's the reason it occupies n plus m space. So therefore its order would be n plus m. Now here are two homework problems for you. You need to solve them. The first answer would be order of n, and the second answer would come out to be order of log n. So do try these problems and comment your answers below in the comment section. So now I'll tell you a bonus question for today, that is, see, if you look at this question, it says void function int n. So n would take how much space? Just 1 unit. But when you come to this array, it is also taking 100 units. So total would be 101 units. That is equal to some constant. So that's the reason it would take order of 1. But many of them would get confused over here, and they would write, since it is of size n, you would directly write it as order of n. But it doesn't happen like this. The reason being, array 100 is a fixed size array. It is fixed. It is having just 100 units. it is also some constant. So that's the reason the space complexity would be order of 1. So hope these concepts are clear for you. Do check out the data structures playlist. I've put that in the description below, and if you like this, then do share it with your friends and comment your opinions below. If you're new to my channel, then don't forget to subscribe to my channel. And that's it for this video. See you in the next video. Until then, bye bye.